The edge detector analyzes the bit stream and determines when the bit stream changes from either high to low or low to high. I'll quickly assemble a bit stream input or Boolean 1D array front panel control. And the derivative operation in the math palette will handle the edge detection task quite nicely. It has a number of different inputs. As it turns out, the only one that we really need, or the only two that we need to set up, are the actual input and then the type of derivative calculation that we need. So I'll establish a constant for that. And there are several different options, and to give you a sense of the correct option to pick, let me quickly assemble a little demonstration bit stream. So we could think of these as a couple regions of low value, high value that are slowly changing, and then maybe a couple quickly changing values at the end. And the first thing we find is that the derivative really does not want to operate on Boolean data type directly. I'll go ahead and convert that to a numerical value. And we still see the coercion dot showing up here, and that has to do with the coercion of an integer data type into double data type. If you want to get rid of that coercion dot, the easiest way would be to look at the data type, which it turns out is integer 16 in this case. That really doesn't matter a whole lot because we can say take anything and convert that to the double data type and then connect that up to the input of the derivative operator. And do just a little bit of cleanup here. I'll create an array indicator so we can take a look at the output being calculated. And if you look closely at this, you see that wherever you have regions of a constant value, you have a 0 output. And in the vicinity of a transition, we have a pair of outputs which are each 0.5. And that's a characteristic of this so-called second order difference. The backwards difference is the one that I recommend for this purpose, because we see that as soon as the transition is detected, we just generate a single value instead of a pair of values. Also, you see that when we have a transition from true to false or from high to low, we get a -1 in the output. So we can use that to distinguish the edge type. So I recommend using the comparators to check for positive and negative values, and that gives you your rising edge and falling edge type outputs. Also, one of the outputs you're looking for is either edge, and the OR gate works nicely for that. So remember not to use the demo input here. Switch that back to your regular bitstream input, and you're all set.